Hi, everybody. This is Mr. Folly. Oop, 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 oop. And welcome to 6.2. Get out your calculator. Yeah. We're going to math it up and math it up and math it up today. So let's do it. Okay. Stoichiometry is reactant to product and product to reactant and reactant to reactant and product to product and heat to reactant and heat to product and product to heat and reactant to heat. It's a bunch of twos, which is really going to be a lot of math. Okay. So these are the questions we're going to do, which is essentially math, okay? So chemical quantities can be converted from one type of substance to another. So notice I have a 1 here for nitrogen, and I need 3 hydrogens for that. And these together will give me 2 NH3s, okay? Coefficients represent particles, which really will be moles of particles, because remember, we're dealing with bajillions and bajillions and bajillions. And we talked before about how a mole is 6.02 E23 particles. Woo, that's a lot, okay? And it's got to be that many because these things have to collide just right. So as I said before, 1 mole needs 3 moles of hydrogen. 1 needs 3. 1 mole will make 2 moles of NH3, all right? So this all comes down to coefficient ratios. So if I start with 5 moles of N2, remember how before we did the copying thing? Whatever my given unit is, if I don't like it, I put it on the bottom. And then I would need or get, let's change that into NH3. How many moles of NH3? So I need a relationship. Remember how these things need to equal each other? The top has to equal the bottom. Well, 2 moles of NH3 will equal 1 mole of N2. That's your coefficient. So 5 times 2, notice how moles of N2 cancel. 5 times 2 is 10, and my unit I'm left over with is moles of NH3. Okay, so moving right along. We need to cancel units. That means your given unit is canceled by putting that on the bottom. Hey, that sounds familiar, right? So notice how, again, my given unit is canceled by putting it on the bottom, and then top and bottom have to equal each other. So these things right here are called mole ratios, and I'm happy to say we don't need to list the mole ratios anymore, but these are equal to each other, and I talked about how they're equal and all the stuff that goes with that. All right, so now we're going to talk about converting from substance A to B. And you're going to hear me say, always go through moles, always go through moles, always go through moles, always go through moles. Write the given. Cancel the given unit and go into what you want. Mole conversion. How do you cancel the given unit? Put it on the bottom. Cancel the top unit and go into what you want. Oh, cancel top unit and go into what you want. Okay, yeah, so then the next step. Okay. Or go to moles, do mole ratio, go to the unit you want. Let's just do some. It'll make more sense. If you have 25 grams of sulfur, how many grams of SO3 form? So write down your given. Okay. Oops, I'm going to change my color here. Nothing else. And then cancel the given unit and go into the unit you want. Grams cancels, go into the unit that you want. Now, see, there's the bad part. The unit you want is going to go into moles, right? So I can't go right from grams of sulfur into grams of SO3 because I have to go through moles. Go through moles, always 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 go through moles. Okay? So on this, then it says cancel the top unit, so this is my top unit now, by putting it on the bottom and go into the unit you want. Well, the unit that I want is grams of SO3, but I can't go right into grams of SO3 because I always go through moles, always go through moles. I need moles of SO3 first. So hopefully you can see that this unit, oops, that's not what I wanted, that this unit cancels here. And then I'm going to do it again, that this unit cancels here. So again, given unit you don't want, put on the bottom, go to moles. Cancel unit, go to moles. Cancel unit, go to your final answer, okay? Mole ratios come from coefficients. Little g means grams, and little g means go to the periodic table, meaning go to the periodic table, that's 32.06. This right here is S plus 3 O's, all right? Math is multiply on top and divide by the bottom, so what I'm doing in my calculator here is I'm doing 25 times 1 times 2 times 80.06 divided by 32 divided by 2 divided by 1. Okay, I want you to put that in your calculator now. I know you just kind of didn't listen to me, but I want you to put it in your calculator now and see if you get the same thing that I do, because there's a lot of times this is a really common mistake. 25 divided by 32.06 times 80.06, and I get 62. So a really common mistake is that people will multiply here. Don't multiply. Okay, it's on the bottom. You're going to divide. Okay, all right. Move to the next one. How many moles of O2 are required to produce 350 grams of SO3? Here we go. Get it where I can see my equation still. So my given, 350 grams of SO3. 350 grams of SO3 times dividing bar. Grams of SO3, cancel that unit. Always go through moles, always go through moles, always go through moles, always go through moles, moles of SO3. Now, right here, moles of O2 is my dream, okay? So that's what I want to go into. I can't go right into moles of O2 yet because I got to go into grams of this. So little g stands for grams and little g stands for go to the periodic table, 80.06. And the number that goes with moles is 1. The only time moles isn't 1 is if I have moles over moles. So notice right now, moles of SO3, but I want moles of O2. I want to get rid of that unit then, moles of SO3 on the bottom, moles of O2 on the top, because I can go from moles of one thing to moles of the other. Moles over moles, use coefficients, 3 over 2. Calculators assemble. 350 divided by 80.06 times 3 divided by 2 is 6.56 moles of O2. How many molecules of our O2 are required to produce 100 grams, I think that's grams, grams of SO3? 100 grams of SO3. This is my bonus question, only because you're in the smartest chemistry class at LTHS. Do you do this? Not on the test is what I'm telling you. 100 grams of SO3. I hate you, grams of SO3. Always go through moles, always go through moles, always go through moles, always go through moles. I'm trying to get molecules of SO3. Okay, that's my dream. So little g means grams and little g means go to the periodic table, 80.06. And that's 1 mole. That's SO3. I hate you, moles of SO3. Moles of SO3. And I want to go into molecules of SO3. How many molecules of, I misread it, molecules of O2. So instead of going right into molecules of O2, I have to first go into moles of O2. Moles of O2, moles over moles, use coefficients, trace, dose. But I don't want moles of O2, so I put moles of O2 on the bottom. I want molecules of O2. 1 mole is that big honking number, 6.02 E23. Again, if the E23s bother you, it's not on the test, but it is in most chemistry classes, so I want you to be ready for your next one. Times 6.02 E23. So 100 divided by 80.06 times 3 divided by 2 times 6.02 second comma 23. And my answer is 1.13 E25 molecules of O2. All right, so now here we go. Heat and stoichiometry. All right, we have endothermic and exothermic. We've done a little endo-exo stuff before. Endo means into. So endothermic means heat is going into the reactants or absorbing the reactants. It feels cold, the temperature goes down. Delta H is positive, and kilojoules will be on the left. Exothermic will release heat. Exo means exit, out. Feels hot, delta H is negative, and kilojoules are on the right. So delta H, tells you the heat is absorbed or released for a balanced reaction. So this is pretty common to have it like this, where it would tell you, hey, look right here, look right here. There's delta H, okay? So delta H is positive, so heat goes on the left-hand side. 178 is the coefficient for calculation, so I rewrite it. And I put it left on the left, or right on the left, or whatever it is, okay? NH4NO3 yields N2O plus 2H2O, and given delta H is, delta H is negative 99 kilojoules per mole. So because it's negative, kilojoules is going to go on the right. Bam, when I'm asked to write it, it'll go on the right. Okay? So then, the math part. Yay, math. Given this equation, CaCO3 yields CaCO plus CO2. Delta H is positive 178. That's my coefficient, right? So what I'm going to do right away, it's positive. I'm going to put 178 kilojoules over here with a plus sign. How many kilojoules of heat energy is involved in the above reaction if 3 moles of CaCO3 were to decompose? Notice 3 moles of CaCO3 cancel. Now, remember how I had our mole ratios of the coefficients? Well, guess what, my friend? Coefficient here is 1. Coefficient here is 178. 178 over 1. So all I do is 3 times 178. I can divide it by 1, but that doesn't do anything. It's kind of like kissing your sister. And that's not something that is worth even mentioning, talking about, or doing. All right, so H2 plus Cl2 yields 2HCl plus 185 kilojoules. How many kilojoules of heat energy, so I'm looking for kilojoules, are released if 5.05 grams of hydrogen, that's my given, react with an excess of chlorine gas? Remember, if it says excess, that means you can ignore it. If I told you I have an excess of paper clips, that means I don't need any more paper clips. So ignore. The word excess means ignore. I have more than enough. All right, so grams, C grams, hello moles, but I want kilojoules. Goodbye moles, hello kilojoules. Why is it 185 and 1? Well, it's 185 and 1 because my coefficients are 185 and 1. I want to warn you, it's not always 1 mole and kilojoules, okay? I just want to make sure you know that. How many molecules of HCl? Honestly, I'm dropping the molecule 1 because it looks like we're running a little long here. Yeah, you can thank me now or later. You'll probably thank me now. How many kilojoules of heat is absorbed if 1,950 grams of KClO3 were to decompose? 1,950 grams of KClO3, and I'm looking for kilojoules. So, given unit is grams, I hate you, grams of KClO3. And I want to go into kilojoules, but I have to go through moles. Always go through moles, always go through moles, always go through moles. So I have to add up KClO3. 39.1 is potassium, plus 35.45 is chlorine, plus 3 times 16, 48, is oxygen, and it's 122.55. Number 1 goes with moles, unless I'm doing moles over moles or heat. So now I'm in grams of KCl, or I got out of grams of KClO3. I'm in moles, but I want kilojoules. So I hate you, moles of KClO3. And I want to go into kilojoules. Hey, I can do that. I can go from moles into anything. So my kilojoules are, my coefficient for kilojoules are 156, and my kilojoules for KClO3 is 2. Calculators assemble, 1950, 1950, divided by 122.55 times 156, divided by 2. 1241 kilojoules. All right, so this is going a little long, so I'm going to finish those other ones up in class, and we're good to go. So to that, I will say, toodles.